Okay, what are the products? This is, let me introduce. This is 3.5. You have questions 4 and 5. Yeah, 4 and 5 are cancelled for this. You don't need them. Okay, but we're gonna go. It's all about titrations. What is true about this? What is the product of the second dissociation of H2SO3 in water? The first dissociation. Oh, yeah, the first dissociation will get you this. Then the second dissociation will get you this. Okay. If I'm not wrong, which let me double check this. Yeah, this is correct. Okay. By the way, for those who don't know, H2SO3 is a weak acid. Okay, it is one of the few weak acids. Question two: what is true? Okay, the indicators you must memorize them all. Okay, methyl orange and phenolphthalein are examples of acid-base indicators. An acid-base indicator provides a visual evidence of the magnitude of H plus in a solution. Right? An acid-base indicator helps determine the endpoint of titration. The endpoint of titration is when the color changes. Right? Obviously, how do you know when the color changes? You need an indicator. Okay, doesn't acid-based indicator slow it down? No, an acid gives the exact amount. Does the indicator tell you there's 0.060 molar concentration of H plus? No. You need to memorize. Let me put phenol. Sorry. This is the table you need to memorize. Litmus, you go no change from red to blue, but it's neutral purple. Thymolphthalein and phenolphthalein are always colorless except for when it's with a base. And I memorized phenolphthalein is P, so it's pink, but thymolphthalein will be blue. Okay, kind of like the litmus. Methyl orange, obviously, normally would be orange. And then acid is red, base is yellow. Okay, so how, like, and I think, base is like, oh, it's chill. So it goes lighter than orange, which is yellow. And then acid is like, oh, like, it's not chill. So it goes darker than orange, which is like red. They're stupid ways to memorize. So, but like, really, they help you get the marks. Wallah. Question three: which of the following is not used during an acid-base titration? Obviously, a Bunsen burner. You don't need to heat at all. In the acid-base titration, guys, please read the notes for titration. They're very, very good. I just need to reach titration. Titration. You have a burette, a pipette, and you have a volumetric flask, and you have a beaker. You either add an acid or a base here, and then up here you add the soluble thing. It's used. It's used usually if in the excess method if you're using a soluble base. Uh, you should know what is the equivalence point, what is the end point. The equivalence point uh, is when la 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 la. Okay, at the equivalence point, I'm gonna, this is a lot of yap here, but you should know that at the equivalence point, the stoichiometric ratios are equal. So that means the ratio n over coefficient for the acid, because you're adding an acid to a base, is equal to the ratio n over coefficient of the base. Okay, you should know this. At equivalence point, the stoichiometric ratios are equal. So, or stoichiometric point of a chemical reaction, okay, it's stoichiometrically equal to the amount of moles of the substance. Okay, la 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 la. The smallest amount of titrant, okay, that is sufficient to fully neutralize or react with. Okay, this is just, yeah. Okay. The titrant is what's in here. Let me just make sure of this. I don't want to say anything that's wrong. The titrant, I wrote it somewhere. Yeah. So in titration, the thing in the burette is called the titrant. In case they ask this, they say what's the titrant, what's the analyte, and this is here the analyte. Okay, the thing that's down here. Okay, during a titration, the volume of the titrant is obtained taking the difference between. Yeah, this comes written part. Really, it comes written. This question always comes. How do you determine the volume of the titrant? It's obtained by taking the difference between the last and first reading of the burette. Okay, it came in a written part in the 2022-2023 term 1 week 11 grade 11 chemistry periodic. Okay, it came and many people got it wrong. It's, let me just double check. Yeah, so what readings they asked, they were talking about titration, and they said what readings should the student take when doing a titration. It's always the difference between the final burette reading and the last reading. You have to say difference between last. So no, what did I just say? Difference between the last and the first. Okay. If you just write first and last, you're gonna lose minus half because you have to say last and first. First say last. Like initially you have to say last, then say first. Because into when reading it, you're gonna subtract the last reading by the first reading. Okay, like let's say مثلا this is my بريت. Taz هيك. Okay, it was here at 20 and then it went down to 15. Okay, I asked myself what was the last reading, the difference between the last and first reading. The last reading was 15, the first reading was 20. So what do you do? 15 minus 20 minus 5. So you lost 5 centimeter cube of whatever, I don't know, let's say you're adding a base NaOH, then you used 5 centimeter cube of NaOH. Okay, always last minus first. It's the difference between the last and first reading of the burette. Okay, at the equivalence point, the number of moles of H plus is equal to the number of moles of OH minus. Okay, these all come yani multiple choice questions, huh? La 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 la. Okay, typical question, guys. Again, please, you should know how to. You should know these notes or know them all. Which is not used. Obviously, we need indicator. We need the conical flask or volumetric flask. Some people call it volumetric. Burette and the stand. Obviously, do we need a Bunsen burner? No. Look here. في Bunsen burner? No. But you do occasionally. You may need a stand. Okay. Question 4. 4 and 5 are cancelled, so we're gonna skip them. Question 6. A student wants to find. Okay, guys, we're gonna go through this very fast. He wants to find H plus and OH minus in H2A. H2A obviously dissociates to form H plus and A, well, I don't know, minus. I don't care about the element, but let's just say this. Is it balanced? No. Now it's balanced. How much H2A do I have? 0.4. How much H plus will I have? It's 2 H plus. What do you do? It becomes 0.8. Okay, so H plus will be 0.8000 to 3SF. And then OH minus, how do you find it? It's always 10 to the minus 14 over 0.8, and you get this. I'm not going to use the calculator. You guys know how to calculate. Question 7. A student is asked to find the pH. Okay, he prepares aqueous solution of hydrochloric acid, HCl, by dissolving 0.08 moles in the volume. So they gave you the N, they gave you the V, build up the calibration mark. How much H plus do I have? If you put 0.08, you're gonna get it wrong, obviously. You want to see how much H plus. What is HCl? It dissociates into H plus and Cl minus, right? This is always how you do it. Enter you want the concentration of HCl, so you compare it to the concentration of H plus. Do I have the concentration given to me? No, because I have the moles and I have the volume. How do I find concentration? It's moles divided by volume. The moles is 0.08 divided by the volume, which is 250 ml, so it's 0.25 liters. You must divide by 1000. And you should get 0.32, but let's see. 0.32. So you get 0.32 moles for HCl. So since they have the same coefficient, that means it's not molar. As the not moles, it should be molar. 0.32 as well, molar concentration for H plus, since they have the same coefficient. To 3SF, you just add a 0 there. Bam. Deduce the pH minus log H plus. صح. Let's go. And I usually use minus log base 10%. I use whatever you want. You can use minus log or minus log base 10. You get the same answer. 0.32. 0.495. They said to 3 decimal place, so 495. Question 8. Okay. Drag and drop. Okay. If you have an acid, you're pouring NaOH. It's a base. What's going to happen to the pH? Obviously, when you add a base, the pH will increase. You have here, you have a base. KOH is a base. And you have nitric acid, which is an acid. If you add an acid, obviously the pH is going to go down. Because acidic pHs are always those who are less than 7. Here you have water. And you're adding NaCl. It's not an acid, it's not a base, it's a salt. So is the pH going to change? No, it's going to stay the same. Question 9. Fill in the blanks with the pH values of each of the following solutions. 0.36 m of HCl. نحن to find pH, it's minus log H plus. صح? Let's see. Let's find H plus. HCl, it's H plus and Cl minus. Same concentration as H plus, since they have the same coefficient. So this is 0.36. This is also 0.36. So I do minus log base 0.36. That's the first one. It's part A. Part B. I'm going to calculate them all then, but let me just first find the thing. NaOH. Can I directly find the H plus? No, I have to first find the OH minus, right? So Na plus and OH minus. How much OH minus? It's the same as NaOH because they have the same coefficient. So 0.62 over here كمان is going to be here at the 0.62. Okay, بس أنا I want H plus. So how do I find H plus? It's 10 to the minus 14 على 0.62. You're going to get, hold up, you get 1 point, just say 1.61 to 2 decimal places. Yeah, just say 1.61 times 10 to the minus 14. Part C, 0.15 molar of HNO3. HNO3 dissociates to get H plus, NO3 minus. Same coefficient, so same concentration. So 0.15 here, 0.15 here. So you're going to be minus log base 0.15. Let's show minus log base. As the minus log base 10, 0.15. And here I should have said minus log base 10, 1.61 times 10 to the minus 14. Now let's calculate them. Part A, minus log base 10, 0. هيدا. I'll just put minus log. It doesn't matter, guys. خلاص عادي. You're going to get 0.44 to 2 decimal places. The second one, minus log this 1.61 times 10 to the power of minus 14. 13.79 to 2 decimal places. Second one, minus log 0.15. You're going to get 0.82. And obviously, now that you know the pH, even if you didn't know what these were, if you knew the pH, obviously you can tell this is a very basic solution, right? Because its pH is very high. It's almost 14. Question 10. A student carries out this exact question. No. No, it's not this one. But something similar to this came in a written part in a previous year. But I will explain it. يعني, of course, I'm going to explain. I'll explain both. An exact, okay, here you're doing a titration of NaOH and an acid-base indicator to find the final concentration of an HCl. Okay, so you have 25 milliliter HCl and an indicator. Okay. You have here some NaOH and you're dipping it. So, an exact measure of volume 25 milliliters of HCl is carried out using a what? Pipette. You want an exact measure. What do you use for exact measurements? Obviously, you use a pipette. The 25 milliliters of HCl is then placed into what? A volumetric flask, or some people say it's what do you call it? Not the thing that's written here. It was in question 2. What was it called? Conical flask, yeah. Volumetric flask, conical flask. And I called volumetric flask. Here they called it Erlenmeyer flask. I just want to make sure it's the same thing. Yeah. Okay. So Erlenmeyer flask is the same as a volumetric flask or a conical flask. Call it a conical flask. It's way better. Don't say volumetric flask. Please say conical flask or whatever. Erlenmeyer flask. Anyway, I call it conical flask. Okay, it's placed into a conical flask, Erlenmeyer flask, whatever. Then we place it here. Then we start dropping some NaOH, right? So NaOH solution is added using a what? Obviously, this is a burette, right? How does the student know that the end point has been reached? What happens at the end point? The color of the solution changes by the acid-base indicator, right? The indicator will change its color. Question 11. Okay, here again, find the pH. Okay, so they gave you the concentration of H plus is this. So you just have, it's a direct application. They gave you the concentration. You can just put minus log the concentration of H plus, which is 10 to the power of minus 2, right? So it's going to be 2. And they want to do decimal place, so put 0.00. And then here, they gave you concentration of OH. There is a formula. You can do, look, you can do this. And then do 14 minus. If you have OH, you can do pH is equal to, if you have OH, with OH, pH is equal to 14 minus log, actually no, put plus, 14 minus, 14 plus log OH minus. I should put the minus inside. Okay, if you want to use log with the OH, you just have to add 14 to it. Like, look, if you did positive log, OH, which is 10 to the power of minus 6, and you do 14 plus minus 6, you get 8. But let's stick to one formula, okay? Let's stick to one formula. And the way I like to do it, I don't want to be fancy, Can I find the H plus if I have OH? Yes, I can. You just do 10 to the power of minus 14 divided by, we have 10 to the power of minus 6. Without using a calculator, you should know this is 10 to the power of minus 8. Okay, so you just do minus log 10 to the power of minus 8. And even you don't even need a calculator for this. You get 8. But let me just show you. Minus log 10 to the power of minus 8. You get 8. Okay, so أول شيء I found the concentration of H plus, and I applied the formula that we all know and love, that the pH is equal to minus log concentration of H plus. Okay, question 12. عندك, okay, this is what came. This is what came in the written part in the 2022-2023 academic year for the same periodic. Okay, 25 milliliters of HCl solution of unknown concentration is titrated using a 0.025 molar NaOH solution. So they put it here. Drag and drop, obviously. You're trying to find, the thing you want to find its concentration is always in your conical flask. Okay, that's how it works. أكيد it's titrated using a 0.025 and NaOH solution. أكيد يعني the NaOH is going to be here. The NaOH is يعني you want to find HCl, the concentration of it, so you put it in the conical flask. Just know like that. Okay, طيب, you have it like this. NaOH here, HCl here. They said when few drops of methyl orange are added to the solution placed in the Erlenmeyer in the flask here, what is the solution going to turn into? If you add methyl orange to this flask, you're adding what? An acid to it, right? It's reacting with an acid. When methyl orange is reacted with an acid, what does it turn? It turns red. If it was with a base, it would turn yellow. بس نحن here, it's turning red. طيب. Later on, if you kept adding NaOH, until the color of the methyl orange turned yellow, if you kept adding NaOH, the methyl orange will eventually turn to the neutral color, which is orange, and then turn into the yellow color. For those who don't know why, you have HCl. It's acidic, right? So it's red. You keep adding NaOH, it's going to eventually turn neutral, right? Because base acid is going to turn neutral, and the color of methyl orange is orange at the neutral point. Keep adding more NaOH, what's it going to turn? It's going to turn basic. طب okay, هلا صارت basic, what's going to be? Yellow. So at the end point, if they ask this question, at the end point it would be yellow. At the equivalence point it would be orange. Before all of that, it will be red. Okay. They said now, if the volume of the NaOH needed to reach the endpoint is 18 milliliters, what is the concentration of the HCl solution? Okay, I'm going to give you this, okay? The ratios, we said N over coefficient of the acid is equal to N over coefficient of the base. You have NaOH, have HCl. This is what I do. They both have the same H, so the coefficient is both 1. So عادي, I don't have to say I don't have to say shit, what am I saying? Yeah, I don't have to say over coefficient. So that means the moles of the acid is equal to the moles of the base. Okay, wait, no. It's N over coefficient. It's CaVa. Hold on. Yeah, mbala. It's N over coefficient is equal of the acid is equal to N over coefficient of the base. But you guys know that N is equal to C times V, right? So that means C times V of the acid, so concentration of acid times volume of the acid is equal to C of the base times volume of the base. Okay, you guys remember from last year C1 V1 is equal to C2 V2. It's basically the same thing, but you're not allowed to write it like this. You have to say AB. Okay, طيب. This is very easy. We have the concentration of the acid. Do we know it? We're trying to find it, right? The HCl. We don't know, so we're going to keep it like this. The volume of the acid, we know how much is it? 25. Okay, so let me rearrange this equation. It's going to be CB VB over VA, right? I just take VA to the other side and divide by it. So this is going to be concentration of the acid is equal to CBVB. So concentration of B, what's the concentration of B? The base, what's the concentration? I'm using 0.025 times the volume of the base. How much NaOH they said? It's 18. Over the volume of the acid, which is 25 milliliter. And if I'm not wrong, you should get 0.018. But let's calculate it. 0.025 times is at 18, over 25, 0.018. Okay. For this example, we had equal hydrogens, so we didn't have to divide by anything. But you're going to see in further examples that you will have to divide because we said n over coefficient. So let's see here. Yeah, so this is how it is. Yeah, I wanted to point out that it's milliliters. I didn't change it to liters because they're both milliliters. For these types of questions where you're doing CAVA, whatever, CBVB, you don't need to change the volume. Only like you'd only have to change it if like مثلا they put for you here dm cube but here milliliter, or like here they put for you liter but here it was milliliter. Okay, you'd have to change it to be the same thing. Okay, but I doubt they'd ever do that. But in case they do, guys, please be prepared for these types of questions. here مثلا you're gonna have to do n over coefficient. So look here. You have 50 milliliters of BaOH2 is titrated using 0.05 molar HCl solution. 15 milliliters of HCl was needed to reach the equivalent point of the titration. So 50 milliliters of BaOH2. We're trying to find the concentration of BaOH2. So by the way, if they ever ask, since you want to find the BaOH2, okay, that means over here in the conical flask or the Erlenmeyer, whatever you want to call it, what do you have here? Since you always have the thing you're trying to find, so it's BaOH2. When the burette شو عندك is the thing you know, it's HCl. So this is a very, very bad drawing. It's like I'm trying to kind of represent what I'm trying to say. Anyway, so we want to calculate the concentration of BaOH2. You have volume, concentration, volume, concentration. What we're going to do, CAVA over coefficient. It was N over coefficient equals N over coefficient. So instead of N, I'm just going to say CAVA is equal to CB VB over coefficient. How do you find your coefficient? What do we have? If you have it in computer part, do it like this. I'm going to also show if you have it in written part what you're going to do. BaOH2 HCl. You have here 2. So here what you have to do, multiply by 2. So for the acid, what's the coefficient? 2. So concentration of acid is how much? 0.075 times the volume of the acid, 15, over the coefficient is how much? 2, equals the concentration of the base, which we're trying to find, because BaOH is the base, times the volume of the base, which is 50, over the coefficient. What's the coefficient? We didn't multiply by anything, so it just stays 1. So what you're going to get, divide by 50 over, like take that. Let's actually find it. 0.05, 0.075 times 15 over 2. You're going to get this. And we want to take the 50 over the other side, so we're going to also divide it by 50. And you're going to get this 2 significant figures stays 0.011. Okay? If you get it in written, how do you write it? Enter, when you titrate. Okay, when you titrate, the base is coming down, or whatever, acid. But anyway, you're going to have, after you titrate, after you start doing the drops and whatever, in the conical flask, you're going to actually have an acid and a base. They're reacting together, right? So it's going to be an acid plus a base. So you say, this is what happens. In conical flask, you're going to write the reaction between the acid and the base. In this case, it's BaOH2 reacts with HCl. You guys know when a base reacts with an acid, what does it form? Forms a salt and water. Okay, everybody should know this. Salt plus base plus acid gets you a salt and the water. It's part of the excess method from the previous section. So what do you get here? What's the salt gonna be? Box up the middle. You're gonna get HNOH. So obviously that's not what we want. So try the other side. Rewrite it like the way I write. I always write. I don't know why I wrote it like this. I always write acid plus base first. I always write the acid first, then the base. I don't know why I wrote it like this. To produce what? Box up the middle, Cl and Ba. You're gonna get BaCl2 because Ba is 2 plus, by the way, and Cl is minus. Also, you can tell Ba is 2 plus because there's a 2 here, so it's for the Ba. You get BaCl2, okay, plus water. طيب. When you balance this, you're gonna see that you need 2 hydrogens, right? You need 2 hydrogens. Actually, no, wait. Oh, you have 2 oxygens. Cl. Yeah, you need to multiply this by 2 because you need 2 Cls, right? So you have 2H here. That's 2, 4. 2. You need 2 oxygens here. So you need to multiply this by 2. Hold up. Yeah. Okay, yeah. Now it's balanced. I don't know why I lagged there, but yeah, now it's balanced. So when you balance it, you get your equation. You're gonna say this is the equation. Hence, then you say n over coefficient of the acid is equal to n over coefficient of the base, and then you say CAVA over coefficient is equal to CBVB over coefficient. You're gonna say at equivalence point, huh? Sorry, at equivalence. Okay, you have to say it's at equivalence this. Okay, and then you just plug in the numbers like we did earlier. La 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 la. You get the same thing we did earlier. I'm not gonna go over the calculations again. But this is what you write if you have a written part. Okay, you have to write the reactions, whatever. But the way they do it in the written part, the way I ask it is they ask it part A, part B, part C. First, actually, they ask you to find, like they ask you to find concentrate. I'll show you. Wait, I'll show you type of question. Here, they ask it like this. Okay, so this is a question that may come in your written. It's a top question. So obviously, I always advise you to solve every question in the notes. They use 25 centimeter cube, 0.05 molar calcium hydroxide. So this is the base. And a few drops of acid base indicator. They were reacting with sulfuric acid, okay? Sulfuric acid needed to react completely with the calcium hydroxide solution is 12.5. So they gave you the volume of the sulfuric acid. Akid, they want you to find the concentration of sulfuric acid. How do they do it? They put part A, B, C. Okay? The first thing they tell you, calculate the number of moles of calcium hydroxide. I think I read this wrong. I don't know. I sat for like 5 minutes. Calculate the number of moles, part A, of calcium hydroxide. I don't know why they... Okay. Okay, obviously the moles of calcium hydroxide is going to be concentration of calcium hydroxide, let's just say base, times volume of the base, right? Okay, and it's going to be N is equal to concentration of calcium hydroxide, we said 0.05, right? Times the volume, which is, let's find it in decimeter cube. So it's going to be 0.025, and you get an answer, okay? And then they say calculate the number of moles of sulfuric acid to react completely with calcium hydroxide. Here, basically, they want you to see sulfuric acid H2SO4, calcium hydroxide CaOH2. Okay, it's given here, huh? Okay, طيب. Oh, shit, wait. How do they... Ah, hold up. I'll go back to that in a bit. But here, they gave you the acid, they gave you the base, okay? They want you to find how many moles of sulfuric acid should react completely with calcium hydroxide. We know N over coefficient, because N over coefficient. Sulfuric acid has 2. Calcium hydroxide also has 2. So the coefficient is over 2 over 2. It doesn't matter. We're dividing by 2 on both sides. So we can just like say it's N over, like N of acid over 2 is equal to N of base over 2. Do we have to write over 2 on both sides? No, right? We can just cancel them out. So you're just going to get N of acid is equal to N of base, right? So let's see. Let me find the moles from part A. I actually need the answer of that times 0.25. You get this 1.25 times 10 minus 3. Okay. This is the moles of calcium hydroxide. نحن in part B, how many moles of sulfuric acid react completely with calcium hydroxide? You see, N over coefficient equals N over coefficient. Since they're both over 2, that means N of the acid is equal to N over the base. How much is N of the base? 1.25 times 10 to the minus 3 from part A. So N of the acid is going to be equal to 1.25 times 10 to the minus 3. That's it. You just say this for part B. For part C, calculate the concentration of the sulfuric acid solution. Do we have the moles? Yes. C is equal to the moles divided by the volume. Okay, so the moles we have 1.25 times 10 to the minus 3 over the volume. How much sulfuric acid volume do I have? It's 12.5. So 12.5 times 10 to the minus 3. And what do you get? Let me see. It's answer over 12.5 times 10 to the power of minus 3. You're going to get 0.1 mole. So you see here, they basically did everything we did here, okay? But they just like, they're making it a bit more complicated. Why I stopped for a second is because here, we're trying to find the concentration of calcium hydroxide, and calcium hydroxide, as they were trying to find the concentration of the acid, but the acid is the one in the burette. So when I said earlier that the one you want to find the concentration of is always down, I was wrong. Okay, I think when they say they titrate something, that means that thing is in the burette. I just want to make sure here. Yeah. So here they're saying BaOH2 is titrated. Yani they put the BaOH2 in the هيدا in the burette. Let me check also in this question label apparatus of titration. They said titration. Okay, just carried out. Like here, Anna, see this is the thing, Anna. How can you know? How can you be for sure? Yeah, yeah. So here, this is wrong. Like I just checked it. Okay, this is wrong. They should they should swap this. This should be here, and this should be up here. Okay, the notes are wrong. Please pay attention to this. So like here, whenever you say something is titrated, that means it should be down. Okay, something like it should be down. Okay, and in general, the thing you're trying to find the concentration of should always be in your conical flask. Okay, don't make this mistake just because they put it in the notes. Yani here, if you say like مثلا here HCl is titrated, that means HCl should be down. Okay, and then here مثلا they said BaOH is titrated, يعني in your هيدا, this is your burette and this is your conical flask. Okay, that means BaOH should be down. Okay, the thing being titrated should be down. The question in the notes is wrong. Okay, question 14. They gave you the pH of a solution is this. Calculate the concentration of H plus and OH minus. Okay, always know that pH is equal to minus log H plus. Also, concentration of H plus is equal to 10 to the power of negative pH. Okay, so it's going to be concentration of H plus is going to be 10 to the power of negative 1.78. Okay, 10 to the power of negative 1.78. This is going to be this 2SF 0.017. Okay, how about OH minus? How do you find it? It's always 10 to the minus 14 divided by whatever this is. So you can put 10 to the power of minus 14 over 0.017 to 2SF. How do you get this? I think you're supposed to use I think you should use, oh no. Yeah. Okay, so 10 to the power of minus 14 over. Oh shit! Hold up. Let's find this first. 10 to the power of minus 14 over 0.017. You get this, okay, and then you go. What am I doing? Wait. 10 to the power of minus 1.78. Find the H plus again. This was this. Okay. Yeah. So you take 10. Why am I lagging, يا 10. Yeah. Now do 10 to the power of minus 14 over. Okay. Yeah. You got this to 2SF. Okay. Or I think you can just do this. Hold up. This over this. Yeah, this would work as well. Okay. Because this is this. So you can just do 10 to the power of minus 14 over 10 to the power of minus 1.78. Don't use the rounded answer. Use the exact answer you got from part A. Okay, like from you get what I mean. Calculate the concentration of H2SO4. Okay, for this part here, calculate the concentration of H2SO4. Usually, they would give us H2SO4 and then ask to find H plus. But basically, you guys know H2SO4 dissociates to form H plus and SO4 2 minus. And if you balance it, 2 here, so you have to put a 2 here. We know the H plus is 0.017, right? And we know that the H plus is actually 2 times H2SO4, right? So if 2 times H2SO4 gives me this, so I can just like take this. And I think this will give you a wrong answer. Yeah, you have to take the exact answer we got from part A. Remember, this was 10 to the power of minus 1.78. So take it and divide it by 2. You're gonna get this 8.3 times 10 to the minus 3. In the exam, if you get anything like this when you have like long decimals, please use the exact values you used from like previous parts. Don't use rounded values to calculate. Okay, the pH of calcium hydroxide was this. Calculate H plus. Okay, same thing. Always the concentration of H plus is 10 to the power of minus pH. So 10 to the power of minus 13.78. You're gonna get 10 to the power of minus 13.78. You get 1.7 times 10 minus 14. Yeah, same thing. Okay, هلا for OH, don't do the same thing as the previous question. We're gonna do 10 to the power of minus 14 divided by H plus. But we're not gonna use this, we're gonna use this. Okay, 10 to the power of minus 13.78. So 10, 10 to the power of minus 14 divided, let's just say answer. You get 0.60 to 2SF. Okay. Calculate the concentration of CaOH2. Same thing, CaOH2, same as last question. It dissociates. By the way, this one dissociates partially, huh? To get Ca2 plus and OH minus. But it's 2 here, so you have to put a 2 here. So that means the concentration of OH is 2 times CaOH, right? So 2 times CaOH gets me the concentration of OH minus, right? And this OH minus is 0.60, so we have to divide by 2 to get the CaOH. So it's the answer we got. Divide by 2, you get 0.30. Okay, to 2 significant figures. Question 16. You have to calculate the concentration of this. Okay, guys, this is very easy. You have HCl. What do you get in HCl? H plus, Cl minus. صح? Okay. Same coefficient, so that means same concentration. If the concentration of HCl is 0.02, then what's the concentration of H plus? Also 0.02, but they just put it in scientific notation. 1, 2, you get 2.0 times 10 to the power of minus 2. OH minus, how do you find it? 10 minus 14 divided by 2.0 times 10 to the power of minus 2. So put this on your calculator. خلاص, man, I don't want to calculate. Let me just fast 10 minus 14 على 2.0 times 10 to the power of minus 2. You get 5 times 10 to 2 SF 5.0. Question 17. 50 ml of 0.2 is titrated, so that means if it's titrated, يعني HCl is gonna be so HCl is gonna be down here. Okay. Yeah, it should be here. The endpoint is reached when 29 milliliters. Okay, whatever. Okay. Remember, when we want to find the concentration in titration, you always do n of the acid. N of coefficient of the acid is equal to n over coefficient of the base. Since they both have 1 to 1, we don't care about this. So n of A is Ca Va. N of B is Cb Vb. Direct application. Concentration of A is 0.2. A يعني acid, huh? Not like it's the first one. Like A acid, B for base. Okay, volume of the acid 50 equals a concentration of the base. We're trying to find it, right? So Cb times the volume of the base, 29. Just put this on your calculator. 0.2 times 50. 2 times 50. And divided by 29. You get, whoa, okay. 3 significant figures, 0.34. Yeah, 0.345. Because 8 is large, so it should be rounded to 345. Question 18. 0.5 gram. Oh my god. 0.5 grams of HCl is dissolved in water to form a 250 milliliter solution. 100 milliliters of HCl solution is titrated using 0.015 molar NaOH solution. Calculate the volume of the base needed to reach the endpoint. Okay, so always when doing this, we said n over coefficient acid, n over coefficient base. HCl, NaOH, there's no coefficient because they both have 1 to 1. HH, right? طيب, n of the acid, Ca Va is equal to Cb Vb. So let's take a look. Do we have the concentration of the acid? We don't. But we have the mass. We have the molar mass. So we can find the moles. And and you have the volume of the solution it was originally dissolved in. And you guys know C is equal to N over V. We can find N over here, and we have the volume over here. So let's find N. It's equal to the mass divided by the molar mass, which is 0.5 divided by 36.5 on our calculator. 0.5 divided by 36.5. You get this, okay? 1 over 73. So C is equal to the moles we just found. Just say the moles, 1 over 73, divided by the volume, 250 milliliters. It has to be in liters, صح? So 0.25. Okay. Why here I changed it to liters? I told you guys if it's milliliters and milliliters, you don't have to. That's for the second part of the question. So when you're finding the concentration initially, you need to use liters. Okay. When you're just finding concentration alone, yani. Okay. So it's gonna be 1 over 73 divided by 0.25. 4 over 73, which is this. Okay, let's just say the concentration of the acid is 4 over 73. I don't want to use decimals. Times the volume of the acid. Now, see here, people are going to get confused. Do I use 250? Do I use 100? You're going to use 100. Why 100? Because in the titration, what am I using? I'm only taking 100 milliliters. So 100. Concentration of the base, 0.15. Times the volume of the base. We don't know it. We're trying to find it. Let's put this in our calculator. 4 over 73, the answer we just found, times 100. Divided by 0.15. You get 36.5 to 3SF. Last question. 50 milliliters of 0.2 molar H2SO4 is titrated using NaOH solution. So if it's being titrated, yani it's here. Okay, so H2SO4. If the volume of NaOH needed to reach the endpoint is 15, what is the concentration of NaOH? Let's see. N over coefficient acid is equal to N over coefficient base. Let's see. The acid has 2H. How much does the base have? It has only 1. So what's the reaction going to look like? It's going to look like this. 2 NaOH. We have to multiply it by 2, so they're equal, right? So what's the coefficient of the base? It's 2. So it's going to be N over 2 times the base. But the coefficient of H2SO4 is just 1. So we're going to keep it as N over 1 is just N. Okay, is equal. Okay, what's the moles of the acid? CaVa is equal to CbVb, but we have to put it over 2. CaVa, concentration of acid 0.2, times volume of the acid 50, equal to the concentration of the base. We're trying to find it, right? So keep it as Cb. Volume of base 15. Let's do it again on our calculator. 0.2 times 50 divided by 15. Oh, we got the wrong answer. We had to divide by 2. I had to divide by 2. I forgot to divide by 2. So 0.2, let me repeat this, 0.2 times 50 divided by 15 over 2. So divided by 15 over 2. You get 1.23 significant figures, 1.33. Okay, 1.33. We're done. 3.5. Thank you so much for watching and good luck.